webcast, Race to Zero, Decarbonization for the Water Sector. A special thank you to today's sponsor, Xylem, and thank you to our presenter, Austin Alexander. Austin is Vice President, Sustainability and Social Impact at Xylem. In this role, she is responsible for Xylem's global sustainability programs, ESG reporting, social impact, and client sustainability programs. This includes working towards Xylem sustainability goals and commitments, which incorporate efforts to build a sustainable company, empower communities, and serve customers. And now I will turn it over to you. Thank you, Austin.
Great. Thank you, Ulrika, and thanks everyone for tuning in. Really appreciate you taking time out of your busy schedules to tune in today. I have about 30 minutes or so of talking points, and then I'd love to answer any questions you have. So please do ask them throughout the presentation, and we'll answer at the end. But I do hope to also hear from you of what you think about this presentation or questions you have. So as mentioned, I lead sustainability and social impact for Xylem. We're a global water technology company of 22,000 employees, providing technology for water, wastewater, commercial buildings, industrial solutions, monitoring, you name it. There's water, we have some technology for it. And I have a little bit of this dual role where I manage our sustainability programs, including in our own Xylem net zero commitment, as well as how we can help the water sector in their decarbonization goals. So I've tried to come from this from both perspectives of lived experience, setting our own net zero target, but also working on water, wastewater utilities, how we can help decarbonize those as well. So again, thanks for taking the time, and I'm really excited to jump in today. So before I get into too many details, I think it's really important to take a moment to think about why net zero and why today. You're probably hearing in the news, COP28, the UN's climate conference, is kicking off this week in Dubai. I'm headed there Saturday. I'm very excited. And there's a lot in the news around our global climate mitigation efforts and how we are or are not achieving the targets we've committed to ourselves. Most importantly, the Paris Agreement, which came out of COP21 several years ago, that 70 countries signed on to meet net zero goals, specifically roughly 50% reduction in emissions by 2030. We're at the halfway mark this year. And so a lot of the conversation you're hearing about in the news this week and probably for the weeks to come is around how we are not on our way towards meeting that commitment. And the countries that have made global greenhouse gas commitments aligned to the Paris Agreement account for roughly 76% of GHG emissions. So that's a good version of, if we can get back on track, we can really make a meaningful effort towards climate mitigation and reducing the impact of climate change. Now, I'm going to get into some specifics here on what exactly are we talking about, because I think it's really important to pause and define what we're using when terms like net zero are thrown around quite a bit. Net zero, we're referring to greenhouse gas emissions, those emissions that contribute to climate change, as reducing that to as close to zero as possible, with that tail end remaining to be either absorbed through carbon capture or sequestration or through offsets. I'm not talking about that tail end carbon sequestration offsets today, rather focused on, if you think about net zero as a curve, that front end, what are the absolute reductions that we can do today within the next 10 years as technology evolves to capture the rest of that tail end? But I do think it's important to note that when talking about net zero, we're talking about the entire value stream of emissions from what's called scope 1 and 2, those emissions that are more or less in the direct control of an entity, in this case a utility, or in my case a company, and scope 3, the upstream and downstream emissions. So let me take a moment to do just a little bit of definition setting before we jump into the nitty-gritty. Scope 1 emissions, which you'll hear about, are those direct emissions controlled by an organization. I say those are emissions within your own four walls of the organization that you have basically direct control over. That includes fuel combustion on site or by your owned equipment, for example, diesel that's burning for dewatering pumps. But it also includes for wastewater utilities, the emissions produced on site from wastewater process, such as methane and nitrous oxide. We'll come back to that in a minute, but for wastewater utilities, process emissions in scope 1 can be quite a significant portion of their total greenhouse gas emissions. Next, scope 2. This is indirect emissions, but still what I would consider generally in control of the organization. So this is typically associated with electricity use, but also steam, heat, cooling, other things like that. So if I turn on the lights in my own facility, I'm not releasing emissions directly at my facility, but I am contributing to emissions upstream for those emissions required to produce electricity via coal power plant or natural gas or other form of electricity production. Again, these are emissions that aren't being released on site, but are considered more or less in control of the organization, or at least within arm's length. And then finally, scope 3 emissions. And these are the emissions either upstream or downstream your organization, but that you still contribute to. So for example, upstream emissions in scope 3 could include those of your suppliers, the companies that you're purchasing equipment from. The downstream emissions could be something like if you're selling fertilizer pellets off the wastewater stream, that could be downstream impacts. These are important to think about because as organizations, we have upstream and downstream impact and influence that we need to take into consideration. Most of today's conversation is going to center around scope 1 and 2, where we have the most direct control, but happy to take any other questions on scope 3 at the end as well. Okay, we did a little bit of the big picture. We did some definition setting, but you may be saying, okay, Austin, water utilities, they got enough on their plate. Why should we be caring about net zero? We must be a small contributor. And actually, I think it's a really important time and a really important moment to take a step back and think about how this can be an opportunity for water, wastewater utilities, and I'd argue the water sector at large can have a meaningful role to play in climate mitigation. And I often think about, when you hear climate conversations or you see pictures of climate change on the news, water is often pictured, whether that's in storm weather events, too much water and flooding scenarios, or too little water in drought and scarcity issues. But it's always as water as the end result or the thing that is impacted, which it most certainly is. Utilities know better than anyone. They will feel the brunt of climate change first. But rarely do we see water talked about as part of the solution, which really it can be. I mean, things as simple as well-managed watersheds and freshwater resources can be a great carbon sink or carbon capture mechanism. But also water utilities in the emissions associated with the operations can also lead the charge and really show what it means to be a decarbonized sector. I mean, if anyone knows sustainability, it's water, wastewater utilities, right? It's what they live and breathe. And water infrastructure accounts for roughly 2% of global greenhouse gas emissions. updated research indicates it may even be a little bit more than that. To put that in context, because while it may seem like a small number, that's roughly the same as the shipping industry, which in recent years has come under quite a bit of scrutiny to move towards decarbonization themselves. So it's a real opportunity for water to take the stage and say, we have an impact here, but we also have a lot of the solutions. Okay. So we've talked about some of the stage setting. It's big, it's daunting, it's often faced as a challenge that needs to be overcome. But I hope if you take anything else away from today's presentation, heading towards net zero and reducing greenhouse gas emissions can also offer wonderful opportunities for other co-benefits, and in addition to leading the rest of the world in decarbonization. So for example, water wastewater utilities can cut electricity costs in half and greenhouse gas emissions in half by using technology that exists today. We're not talking about new things or things that are on the new technology yet to come. A lot of the things exist right now that can have other co-benefits. Generally, this is an OpEx cost. The other takeaway I want to demonstrate on the opportunity is, and I know this from experience having set the net zero goal for Xylem, it can feel really big and daunting. And sometimes if you're working on this in your organization, can feel a little bit isolated as you're trying to think about how to scope out all of the emissions in an organization and set a target. But you should know you're not alone. Over 80 utilities globally have set clear net zero goals, and well into the thousands of cities or municipalities globally have set net zero goals that implicate their utilities. And many, many more have started down the journey. Even if they haven't explicitly stated a net zero target, there's many others that have set a greenhouse gas reduction target or some other kind of assessment of their greenhouse gas emissions. So you're not alone. There's many others on this journey. I'm going to go through a few examples of projects that we've been associated with in Germany, the US, and in the UK as some teasers of some of the things you can do along this journey. Okay, so let's jump into the meat of it. And I think, it's easy to take that big daunting goal of net zero and having to convince all your stakeholders to go net zero. It can be quite daunting. And so what we've tried to do is break this into 4 more or less steps or pathways to get to net zero. And oftentimes when we hear net zero, we jump directly to the end. Offsets, carbon capture, or in wastewater scenarios, perhaps waste to energy production. Those are all really good, but big ticket items. Don't start there. In fact, what I'm going to argue today and walk you through is, in fact, there's a lot we can do up front that's more or less easy or has other co-benefits that can start down the net zero journey without having to jump directly to the end. And we break it into 4 steps of how to set baseline and targets, optimizing your existing assets today, or as I'll say, use what you got better. Thinking about the medium term, capital planning projects, that 3 to 7 year timeline of projects in your pipeline. And then think about those big ticket items. Do that last, but that will kind of close the rest of the gap to net zero. So this is what I'm going to walk through here. And the first is, you can't set a goal if you don't know where you are today. You can't set a weight loss goal if you don't know how much you weigh today, or like anything else, you need to know your baseline. And this can be a bit of a daunting exercise, but it doesn't have to be. It is also incredibly important to do this first. Take stock of where you're at right now. And doing this across all value chain emissions, scope 1, 2, and 3, is really helpful to understand not only what to set your goal as, but also to start understanding where you can have the most impact. While you're doing this, the other thing to take in mind is these are typically long-term goals, 10, 20, 30-year targets that you're looking at setting at. It's really important to use that opportunity of baseline setting and target setting to also look at what are your other organizational long-term goals and try to find those co-benefits or alignments. It could be things like reduced OpEx costs or non-revenue water targets. We'll go through a few examples later in the presentation, but it really is important to take stock of how this goal can tie, contribute, or even conflict other long-term organizational goals you have. So we'll walk through that. The other thing I want to mention is, this is a really great opportunity to pull in digital tools as a way to help solve setting your baseline and understanding where you're at. There's a lot of tools out there today. We, as Xylem, have some of them, but there's others on the market as well that can help you set an assessment of where you're at. Or bringing in a third party as well can be useful depending on where you are in your journey. This is something that can be quite helpful in getting that data up front so you know where to go. The final thing I'll say on this is, it can be quite uncomfortable. I know from my own experience, even at Xylem, but it's really important to be open and transparent as part of this process. You're not going to have all the answers right away. Net zero is a long-term goal. There are things you won't know. There are things you won't have visibility to yet, and it's okay. Doing your best to get as much transparent information as you can today and letting your stakeholders know that you've started on this journey is a wonderful way to bring them in as you have learnings in the coming years of you may not have realized there's emissions associated over here, or this is a bigger impact than I realized. That's okay. You're going to learn along the way. And being transparent about it up front is actually quite helpful to your organization, your stakeholders, and frankly, other utilities as they're starting on their journey. Okay, so you've done that. You've set the baseline, you've set some targets, you know where you need to attack. You probably now have a picture of where some of the quote unquote low hanging fruit, I hate that term, but I'll use it, that you can go after. So there's a lot of things that have direct co-benefits with other activities you're probably already looking to do. And that's optimizing, typically on energy, but potentially other areas, optimizing in your assets. So first, some areas to look at are first inefficient legacy assets. So that can be, low motor efficiencies, unsteady flow rates, areas where you may have a set control parameter, but it really hasn't been touched in many years. These are great areas to say okay, this really isn't running as efficient as it can, but a few tweaks can really make some impacts on energy or other process related emissions. We'll come to an example on that in just a minute. The other is on underperforming assets. So typically a place to look here is in rotating equipment. If they're not working at the most optimal high efficiency, or maybe it's something as simple as some service work would really ramp up efficiency, but also things like, really over-designed assets that are operating way above what they need to and are creating a lot of waste in the system that's frankly unnecessary. Finally, aging infrastructure can be a big contributor to a utility's greenhouse gas portfolio. And that's looking, even outside of the plant, but really outside the fence into the collection or distribution systems. So example, non-revenue water can be a great place to attack that has co-benefits likely you had for other goals as a utility. But if you have non-revenue water, let's say in the 15 to 20% range, that's 15 to 20% extra energy you're producing that you don't need to. It also has great benefits for OpEx costs, revenue, and just a more efficient system that you're probably looking to address anyways. Attach the greenhouse gas target alongside it. Okay, so there's some areas to look you know the spots to go, you know better than anybody. But how do you actually go about it? And this is where I think you pulling in colleagues in your organization is really helpful. Net zero is typically not successful if a CEO or leader of an organization says we're going to net zero and it's done. It's most successful when you have all the colleagues, no matter what kind of organization you are, working towards this, understanding it, and making an influence. This whole optimization area is the best way to do this. And I'll give an example from Xylem's experience that I think is quite applicable to many other organizations. So several years ago, we were setting out our own electricity-related benchmarking. What are we doing for greenhouse gas emissions related to electricity? And we started what we call, quote unquote, treasure hunts. And it was really easy. A checklist of things to check for our different sites. In Xylem today, we have over 500 facilities, a lot of manufacturing facilities, but also service sites. Putting that checklist in the hands of colleagues on the ground and saying, hey, here's some things to go look for of where you might have extra energy that doesn't need to be used. For example, are we running the air conditioning system at night when nobody's in the building? Things like that. That checklist for us delivered roughly over 10% electricity emissions reductions just by putting that checklist in the hands of the people that know the facilities the best. It's a great way to go out and say, here's some things to look for. But we found ideas back that were not even on that list of other things of, I wonder why we're operating this piece of equipment 24/7, or can we do something different in this process? It's a great way to educate colleagues, but also start making those small changes that over time really add up. It's a great time to also look at, evaluating energy resources. Where are you sourcing your electricity? Great opportunity to have a conversation with your electric utility provider on what they can offer for renewable sources, etc. And a great place to start adding in monitoring. You know your baseline, but adding in some regular monitoring systems or check-ins will help you know how you're progressing. So as we think about this, deploying using what you got better, in short, it's about optimizing the assets you already have, using digital where it makes sense, or especially digital twin technology, looking at your collection and distribution systems, leak detection and condition assessments, and working with your electricity provider to see what are other sustainable energy production or purchases that you can do at low to no cost. That's the easy stuff, right? But it gets us on our path. And I'm going to use an example. This is from a utility in Germany, Cuxhaven, Germany, that was probably like many utilities here in the US, serving roughly 400,000 people, has a set of energy intensive technologies from aerators, blowers, diffusers, the same equipment at most utilities, that were really taking up more than 50% of their energy consumption just there in one section of the treatment section of the plant. And until recently, Cuxhaven, like many utilities, had this equipment running at that set design point for controls and really didn't pay much attention or go back to that. Let it run at what it was set at. So the first thing that we partnered with Cuxhaven on was to implement some virtual sensors in their aeration basin that's looking at their incoming carbon, nitrogen, phosphorus loads, and a digital twin overlay for the plant that looks at what are the actual loads coming in and what do we actually need to treat for and what do we actually need to run the aerators at. This helped the utility make some smart choices on simply, again, using what they already have just a little bit smarter. They reduced their aeration energy consumption by 30%, which, to put that in context, is running 275 homes for a year. So it's not nothing. This obviously has OpEx cost, operational cost efficiencies, And also just a wonderful story to tell the residents of Cuxhaven of how they're making smart decisions with equipment they already have, some minor upgrades, and some pretty big results. Okay, so we've done the first set of optimizing what you got, using it better. Now it's time to look at that medium term, that capital planning. You know, typically that's that 2 to 7 year, 10-year planning of capital projects coming underway, whether new construction or refurbishments that are in the pipeline. And this is where, always encourage, don't create a new process for net zero. Fit net zero into your existing process, things that you're already doing today. That applies whether you're a business like Xylem or you're a utility or something else. So this is where, take those existing capital planning projects, you probably have a list of some sort, and start thinking about where we can make some smart adjustments. Some suggestions. First, look at those projects and what are some specific project KPIs you can put ahead of even moving to design stage. So for example, let's say you have a legacy pumping station that you need to refurbish in the next 5 years. Can you tell the design engineer or whoever you're working with to say, whatever we do, I want to see a 20% reduction in energy use? Or it's a new construction and it's designed at a fairly large footprint. You can ask, can you design this with 10% less footprint, which means 10% less concrete and thus embedded emissions associated with the concrete. Putting those KPIs in now, as you're starting the capital planning process, can really make some big contributions. This can really, other areas to be watching out for is metrology, so on clean water distribution, moving to things like AMI technology versus drive-by can reduce your emissions associated with the fleet quite a bit, as well as remote asset management for pumping stations, etc. So you're not driving all the time because that's emissions associated with your portfolio. Or like the Cuxhaven system, where we create a digital overlay of your treatment process so you can get a better understanding. You're probably making improvements in these areas over the next 10 years anyways. Let's start adding some KPIs. And finally, I'm going to mention this, and as a supplier, Xylem, we provide equipment to utilities. I may be kicking myself in the butt for saying this, but demand more of your suppliers. If you ask up front, hey, supplier, I want to see equipment that reduces my energy by 20%. If you don't ask the question, no, we won't know what to give you. And it also drives the suppliers to know where they need to invest. So put it on your suppliers, your design engineers, your contractors, put a little pressure on us to give you that information. It will help us know what you want to know so we can make investments in those areas. So let me move to another example on South Bend, Indiana. This is a relatively older example. It's about 10 years old, but I love it, so I keep using it. And it's a problem, quite familiar in the US. City of South Bend, they were under EPA consent decree for combined sewer overflows into the St. Joseph River. Every time there was a rain event, they were having CSO issues right in the river that goes through downtown South Bend. The estimated cost to approve it was over $700 million to do the traditional storage tank, highly capital intensive project that, frankly has been the solution for many years now. What South Bend did is they took a moment and said, all right, let's first install monitoring systems throughout their sewage collection network. Little sensors throughout the network that could tell them flow, levels, etc. And they created a digital twin of their sewer network system. Through that, the machine learning told them as a storm comes in, where to use their existing infrastructure, move what needs to be moved, so they're ready when the storm event hits. That digital system, along with some small smart upgrades on the pump stations where they knew they had the weak points, They reduced their costs, I think, and forgive me for not having the final number on this page, but I believe it was all in the end was a roughly $200 million investment, which is a pretty big savings from where they were. This also eliminated the CSO by over 80%. They had a reduced OPEX cost, annual operating costs of 1.5 million, and E. coli concentrations in the St. Joseph River went down by 50%. There's not only emissions associated with CSOs, but this is just smarter use of the system they already have with some smart upgrades in their capital planning. Okay, so we've thought about that, the most immediate, the medium term, now the long term. This is where a lot of people's minds go, and this is where I say, save this for last. The plan for the future. What are those big ticket items? We're talking 10 to 20 years that are going to take a lot of, internal stakeholder engagement, but can really close that net zero gap for you. For wastewater utilities, this is often in those process emissions. First of all, I like to say this is a great place to start, if you haven't already, and many already have, start communicating about wastewater as a resource versus a waste. You have, frankly, a little energy production plant right in our wastewater treatment plant, as well as byproducts that can be used in other avenues. So starting to change that conversation, a really effective thing that some utilities are doing today is taking their wastewater and doing a waste to energy process right off of it, or resource recovery systems. These take a bit more planning, to be certain, but they are things that really think about changing our mindset from wastewater to really resource recovery. And it's a wonderful way to engage community members and other stakeholders as education on this is a lot more than just a wastewater treatment plant. It's really a resource for the community. An example here that we reference is Thames Water. They're in the UK. They serve the London area. They have roughly 140 million cubic meters of green biogas that they produce off of their treatment plant that's used in power stations and cogeneration facilities to generate electricity and heat. Wonderful, wonderful, wonderful way to power all that other electricity needs you have in your utility, but also doing something really good for the community in a renewable resource. I know I said about 30 minutes, so I'm pretty close here. I'll run with just a couple key takeaways. First is there's no bones about it. Setting a net zero greenhouse gas commitment is bold, and it does require innovative thinking. This is not easy, to be clear, but it means thinking about things differently, and it's a great forcing mechanism to think about other processes in the utility day-to-day operations that can be done differently or with a little bit more innovation. The other thing, and I'm telling you this as Xylem, we don't have a single technology solution to solve net zero. No one does. It doesn't exist today. But like any good solution, it requires a combination of smart moves together, as well as a little bit of innovative thinking to get there. Nobody can come to you and say, well, we're going to get you to net zero tomorrow. It won't happen. But rather thinking about the full system a little bit more innovatively, putting pressure on your suppliers and design engineers to help you get there will help close that gap. And the other kind of takeaway I hope you take is that this doesn't have to be a huge cost investment, but rather a lot of the things, especially those things to do in the next short term, can often have other co-benefits, both in costs and can be your affordability, but also in other areas, whether that's non-revenue water, CSOs, etc. And finally, building smarter, more data-driven decisions on net zero, it helps drive more smarter decision-making areas in other areas of the business operations or the utility operations. So let this be a forcing mechanism of smarter overall operations. Before I move to questions, I'd love to hear from you. Is this resonating? Is it not? We have an email, netzero@xylem.com. Any questions on this topic, also reach out to me directly. Austin Alexander at Xylem.com. Love to hear from you. But you're not alone. There's a lot of utilities working on this today. And as we move into COP28 kicking off this week, a conversation that will be happening there is around water, wastewater utility decarbonization. And there are many others of you out there working on this issue. And so, where we can build collaboration and connection, if I can be a conduit for that, please let me know, because it can be a little lonely journey and you have many others on the path with you that can be wonderful resources. So with that, Lurika, I'll open it up to Q&A if we have any.
Perfect. We do. So we have a question that came in from Ed. Did the German WWTP example include chemical reduction of the carbon source for denitrification?
Yes, thanks for the question, Ed. So yes, this did optimize where most of the greenhouse gas benefits came through were aeration energy reductions. There were some, reductions in chemical inputs that did also reduce that GHG footprint, although relatively quite a bit smaller than the benefits gained from electricity reduction.
Thank you. Is there an equivalent to scope 1, 2, and 3 for water consumption?
A really, really good question, and I haven't seen anything. There's a number of different organizations out in the world that are looking at this and setting different types of parameters around how to think about water in the same way. I'll say this, I'll give my opinion, that's my personal opinion. When we're talking about greenhouse gas emissions, we can't apply necessarily the same model, scope 1, 2, and 3, to water, because water has so many parameters. You on the phone are water experts, you know this. It's quality, it's quantity, it's reuse versus recycle. And so there are organizations looking at different parameters that can be measured, but I have not seen any that I would put my hat on that are as clear and distinct as scope 1, 2, and 3 are for greenhouse gas emissions.
Thank you. Darlington asks, can you expand on what virtual sensors for carbon, nitrogen, and phosphorus look like in the German WWTP example? I'm sorry. I'm sorry. I may have mispronounced it.
I'm following right along, Lurika. You're doing great.
Okay.
You understood the question. Thank you. I think it was Darlington, I think is what you said the name was. If you don't mind, reach out to me directly. I'll send you the exact case study that has more of the technology definition in there. But essentially, it's in your treatment plant, in water sensors that are detecting different components, and you can move it to what you need it to move to. Now look, nitrogenous oxide is really difficult to measure directly, so really nitrogen, phosphorus are what it's measuring as a kind of proxy for other emissions components. But I'd be really happy to send you the exact technology that was used if you'd like to look into it more.
Thank you. And then Ed asked, if the GHG reduction metric were biogas utilization, would you or have you performed a digital twin solution to simulate benefits of CHP versus RNG?
Okay. Ed, really good question. I don't have any examples that are coming to the top of my mind right now, but I'm happy to look into it a little bit more. Why don't I think about that a bit more and I'll get back to you, Ed, or if you can email me, that'd be even better. So I have your email in my inbox and I'd be happy to look. There's no examples that are on simulating benefits of CHP versus renewable natural gas that are popping to my mind right now, but it may just be the afternoon. So I will give it a think.
Thank you. John asks, most states have regulations that require pump stations be designed to handle 20-year projected peak flows. Have any state regulators made adjustments to these requirements in light of GHG reductions?
Another excellent question, John. Thank you for asking that. I'm not aware of any states adjusting their regulations specifically so that pump stations can meet GHG reduction targets. However, I will note that there are a number of technologies out there or different systems that can still have capacity for the 20-year projected peak flow so that the design still meets the regulated standard, but can operate day to day at a much lower or day-to-day average flow. That can be utilized through things you're well familiar with, whether that's VFD or other control systems. But using that technology, I think, is a much faster way to get there than changing the regulation. As far as I'm aware, I haven't heard of any states changing specifically to meet GHG targets. So I think we'll be living with that peak design requirement for a while, but rather how can we use technology to adjust for the day-to-day and meet capacity if someday we do need it.
Thank you. Ed asks, will Xylem be represented at COP28 in any fashion?
Thanks, Ed. Yes, yes, we will. I'm actually flying there on Saturday. I'll be participating in COP28 in the Water Pavilion. Actually, Xylem's co-hosting the day Water for Net Zero, where we'll have a lot of workshops on specifically water, wastewater utility decarbonization, but also water and its role for other decarbonization. For example, as the energy sector decarbonize, what do they need to think about with regards to water? But we'll also be participating in a number of other forums throughout the week. So if you stay tuned to our social channels, I'm sure we'll be posting a lot there, and I'm definitely looking forward to heading out to the desert for the event and seeing what I learn.
Thank you. And then we did have a comment from Glenn. Anaerobic digestion to bio, CNG, and or CHP continue to scale down to smaller plants, but strengthening the importance of GHG reduction in valuation and decision-making would certainly increase the applicability and would have very positive rate of sites adopting it.
Yeah, thanks, Glenn. I mean, I know it's not a question, but, couldn't agree more that like many other technology adoptions, anaerobic digestion GHG is often one benefit that we should be listing among others that can have also benefits. It's just another tool in our toolbox of implementing new technologies or improvements. Also looking at the GHG component can be helpful, but it's rarely, if ever, the only benefit available. And so it's great if we can use that to help advance things like the biogas solutions. So thanks, Glenn.
And that was all the questions that we have for today. Thank you.
Great. Well, thank you so much. Thanks for the questions, and thanks for everyone that tuned in your afternoon or morning. I certainly appreciate it that you listened to me drone on for a bit. Again, if you have any questions, comments, feedback, I'd love to hear it. You can email me directly, austinalexander@xyleminc.com. Or we have a dedicated email address to this topic, netzero@xylem.com. We would be delighted to hear any questions you have. We also have a white paper on this topic, and the link is below. And I believe Sarah from the Xylem team also put a link in the chat that takes you directly to our Xylem website, and we have a white paper on exactly this topic, more detail on those case studies as well. So we'd love to hear from you. So thank you again so much. Really appreciate the time.
Thank you, Austin, and thank you to today's sponsor as well, Xylem. And thank you all for attending.